So yeah, so the slides are for 20 minutes, so we're gonna do them in 5. So yeah, somehow I look at the session, I thought like, wow, I got 20 minutes. Anyways, so yeah, I want to talk about the code sharing, and that's a collaboration between University of Southern California, Suceava University in Romania, Sage Bionetwork, where I'm currently in, and Technical University of Moldova. So at Sage, we believe in open science, so that's part of that, open science, data reproducibility. And everything I will be talking about, that's a highlight talk. Everything is in the paper, published in PeerG Computer Science. So this is Nitesh and Ram, the students were leading, and that was collaboration with GigaScience, with Nicole Nagoy from GigaScience. So one thing I want to say, we're moving to data-centric world, and bioinformatics becomes a center of that. So code sharing and data sharing is part of that. It's a very essential component. But in order to go there, we need well-documented analytical code and data to be available, structured, delivered to the community. And that's part of computational reproducibility, right? Like we would like to be able to reproduce all the results published if data, code, and the environment are provided. So our goal was to explore the patterns in code sharing across the biomedical research. So this is what we did. So we took 10 papers per journal across from 2016 to 2021, and we looked for the papers which have some data. It's not like commentary and things like that, and we try to see, do they share the code? So the things we have looked at was code availability, data availability statement, in other words, how the paper was structured, and journal policy, and analysis type. Was it primary analysis of the data? Was it secondary analysis of the data? So what we see, we kind of see 50-50, right? So formally speaking, the majority do not share the code, but it's close to 50-50. So the good news, things are improving over time. So we started with just 7% code sharing in 2016, and now in 21, it was almost 50%. And probably if we look across the recent years, hopefully the trends goes in. So as you would expect, GitHub is the most popular platform to share the data. So over 75% of the data was shared on the GitHub, followed by other websites, personal websites, as well as supplementary materials, but also other code sharing platforms. So despite, I guess, some excitement in the community in terms of notebooks, we didn't see much happening in terms of organizing the code. So the code was not, in majority of the cases, was not organized as the Jupyter notebooks or any sort of other notebooks as Arc Markdown document and things like that. So interestingly, the studies which are performing secondary analysis of the data, they typically are sharing code better than the primary analysis, the studies which are performing primary analysis of the data. So there is a limited co-availability of code of the data. There is only around a third of the studies which share both code and the data. Oftentimes the data is available, but the code is not available. And there is some fraction, one quarter of the studies which share neither. Across the years, that kind of ratio did not change much. There is still a substantial number of studies sharing the data, but not the code. So in general, data sharing was more prevalent practice than the code sharing, where if you take the primary analysis studies, and this is what we could take because the secondary analysis studies, they do not share the data. So we see that in primary analysis studies, majority don't share the code, as data sharing is opposite. Majority of the study do share the data. So what helps? So we noticed that the code availability statement, this is the statement you have in the paper, usually in the end, where you say about your code, helps. So if you do have code availability statement, it kind of will predict that you share the code. Only the small fraction of the papers which has code availability statement did not share the code. So there are many papers which have both data availability statement and code availability statement, but there are quite a big number of the papers which has only data availability statement and lack the code availability statement. So if you look across the journals, so we looked across 8 journals in bioinformatics and computational biology. So some of them encourage the code, some of them mandate the code. And what we see, mandating the code helps. So there is significant difference where it helps to share the code. So I think I can skip that. So interestingly, across the journal was interesting trends. So bioinformatics was the best journal where majority of the papers, vast majority of the papers were sharing the code. Nucleic acid research was surprisingly a small number of papers sharing the code. And the different story about data availability. So genome biology was the leading journal where a very tiny fraction of the data was not shared. Okay, so we come up with some actions. I can skip them. You can read them in the paper. Future work, we try to extend the study. And open questions. That's something I guess would be nice to discuss. We formulated them, but that's not a complete list. And the funding was coming from Romanian government, sponsored by EU. And yeah, so talk to us at Sage. We're here. Our CEO is here. So many of us are here. Talk about us. We do like cool science and would like to talk about cool science. Thank you.